We present Deep Single Image Manipulation by Yael Winker, Eliyahu Horvitz, Nir Tzabari, and Yedid Choshen. Users often wish to manipulate images. Consider this image, for example. We may wish to change the position of the nose or tilt the eyebrows. Manipulating the pixels of the image directly is typically very hard for humans. One alternative way of manipulating images is by representing them as simpler primitives and manipulating the primitives. One example of a primitive representation is the edge map. Other primitives include semantic or instant segmentation maps of the image. After manipulating the primitives, we then need to map the primitives back to photorealistic images. The mapping can be performed using a deep neural network. Popular methods include Pix-to-Pix HD. The described image manipulation paradigm suffers from two notable issues. First, training a primitive-to-image network, for example using Pix-to-Pix HD, typically requires a large training dataset. Although large datasets are available for the most popular image categories such as faces, cars, or cats, unfortunately datasets for the long tail of less frequent images are not available. Another issue is that when trained on a large dataset, the mapping network may not map the primitive to a similar image, losing the original identity. In order to overcome the issues we mentioned, we propose a new approach which we name Deep Single Image Manipulation, or DeepSim. Our method learns a mapping network based on just a single pair of primitive and original images. We expand the single image pair into a large paired training dataset. We then train a primitive-to-image mapping network on the expanded dataset. We expand the dataset by performing the same random augmentation on the primitive and original images. One way of doing this is by performing random cropping and horizontal flipping. However, this simple augmentation does not result in sufficient variation. Instead, we propose to perform the augmentation using a random thin plate spline, in short TPS Augmentation. The TPS transformation is smooth but highly non-affine, which dramatically broadens the range of manipulations available in the expanded dataset. During training, we randomly sample a TPS transformation and equally warp the primitive and original images. We then optimize a Pix-to-Pix HD network using the warped primitive as input and warped photo as output. This is done for 16,000 random warps. Let's see some results. This space is represented using the edge primitive. By manipulating the primitive image, we are able to move the nose. Another manipulation of the primitive image tilts the eyebrows. This car is represented using a segmentation primitive. By manipulating the primitive image, we are able to add a third wheel to the car. Another manipulation of the primitive image transfigures the sedan into a sports car. The edge representation allows fine manipulation but has weak generalization properties, for example the eye of the bird. Segmentation maps generalize well but do not allow fine control, for example consider the loss of detail in the background. We propose a new representation which we name the super primitive. This representation consists of the edge and segmentation maps overlaid together. It combines the strengths of both representations, allowing for fine control and good generalization. Notice the detailed background and sharp eye after rotating the head. We present another example. This image consists of 3 cars. We represent it using the super primitive. By removing the car on the left and completing the missing edges, we are able to completely remove the leftmost car. By switching the segmentations of the cars and completing the edges at the back, we are able to switch the positions of the rightmost cars. We also presented a novel way of numerically evaluating single image manipulation methods based on video datasets. Our method performs much better than the baseline, resulting in much smoother generated videos. To summarize, we presented DeepSim, a new method for learning image manipulation from a single pair of images. Differently from other methods, our method does not require a large dataset and preserves the original image identity with high fidelity. Please consult our archived manuscript for more details and results. Our code is available on GitHub. Thank you for listening.